think we just made it under the wire.
Oh.
So if you're ready.
I'm ready.
Okay. Hello, everyone. I'm Anthony Odell. I work here at ONRC, coordinating toxic plankton monitoring program with staff scientists here. And tonight I have the great honor of introducing Dr. Tom Rosmond. And we have a short bio I'd like to give. Tom Rosmond grew up in Forks, graduating from Forks High School in 1962. He went to the University of Washington, received a PhD in atmospheric sciences in 1972, the year I was born. He spent 30 years as a research meteorologist for the Marine Meteorology Division of the Naval Research Laboratory in Monterey, California, followed by another 10 years as a contractor for the same organization. In 2004, he received the Fred E. Salthold Award from the Chief of Naval Research for outstanding lifetime achievement in science for his development of the Naval Operational Global Atmospheric Prediction System. He currently lives in Forks area and is a board president of the Forks Timber Museum and is a fire commissioner for the McClellan County Fire District 6. ONRC Rosmond Evening Talks is funded through the Rosmond Family Education Fund and endowment that honors the contributions of Fred Rosmond and his family to forestry in the Forks community. And with that,
Thank you. Just out of curiosity, of course, we don't have, there isn't as big an audience this time as there was 11 years ago, because we didn't have Zoom back then. I wanted to see that be here. But how many of you actually were here at that original talk 11 years ago? Anybody? Oh, great. This is all going to be new material. I'm pretty sure that there are probably some people that are on Zoom. Anyway, at that time, 11 years ago, it was just before the Super Bowl when Seahawks and the Broncos were going to play. And there was a lot of hand wringing at the time because it was being played in New Jersey, concerned that it might snow. So that was one of the things that I talked about. Was there was going to snow in New Jersey in 2 weeks in the future, and I said, well, there isn't much. Maybe we don't really make forecasts 2 years in advance. Depend on it. So anyway, that's. But this year it's being played in New Orleans, indoors, and the Seahawks are playing schools. It's worried about that. So what I'm going to talk about now is what I call the industry of weather prediction. I'm using that term because I was kind of motivated by a book that I found. It's written by a journalist. The title is The Weather Machine. And basically, we talked to them quite a bit about the sort of things that I'm going to talk about now. If anybody's interested, I think Chip, you can give it to me. It's quite interesting because it's written, as I say, by a journalist. So he didn't know anything about it and wanted to find out about how this whole process works. And I'm going to say a little bit about that here as well. So going on, it's big science. I say that made it comparable to a big business. So what is big science? Depends on complex, expensive facilities. Our business, you've got supercomputers, you've got satellite systems costing millions, even billions of dollars. A lot of money involved. Lots of international cooperation. Everybody has weather. And this is one of the few places where international cooperation historically has worked very well. There is the exception, not the rule. Sure, there. It's a source of national prestige to be in this big science business. When I was in Monterey, it was really not part of my Navy job. I actually participated in bringing a global MVP system to Taiwan because they wanted to be part of the big time. So we helped them procure a supercomputer in the global forecasting. Other examples, theoretical and algorithmic particle physics. Cyclotrons, particle accelerators, things like that. Fusion reactors, trying to make them work. Astronomy and astrophysics. Space telescopes. Big multi-international cooperation with places like the Atacama Desert, in Chile where they have a lot of belt schools. Weather prediction is unique on these things because it's the application of fundamental science to direct immediate benefits to society. And that's sometimes a burden because weather is part of everyday lives and therefore it doesn't have the mystique that some things like elementary particle physics has. We don't even know what that means. We all think we have a pretty good idea what the weather is. So the outline of what I'm going to talk here is, what is this industry? How is it like an industry? How is it like a large and multinational manufacturing? Big business versus big science. So it's comparison. First thing you have to do, you have to extract raw materials. I'm going to use here companies like warehouse, forest industries. They have their own forest, they do their own logging. So they have raw materials. In the weather business, we take observations. We have the data. We produce a product. In our business, it's the numerical guidance, it's the output of the numerical models. The atmosphere, just like Weyerhaeuser probably has, they have sawmills, producing lumber. Then you have marketing and sales. You have sell users. Weyerhaeuser sells wholesale to places like the number of places to sell. And the mill works, for example. In our business, public forecasts, stuff you see on the evening news, the weather forecast, the apps on your phone, the weather channel. And then I'm going to also then talk, which is kind of one of the unique things about my talk tonight, because I'm going to talk about what AI will mean to all three of these phases. I think that's kind of where the world is going to be going in a lot of places. And I want to talk about how it's going to affect the business that I was in. We're going to talk about the quality control of observations. It's going to be used to do things we haven't been able to do before. Observations. How the production of numerical model codes, because that's the business I was in. That's what I do. I do these codes. And is AI taking my job? Thought about that. And actually show some examples. And the delivery of weather forecasts to the public. As I said, the AI is those weather apps you have in your phone. A lot of that stuff is probably being generated by artificial intelligence. Then we'll end up with some discussions. So we're going to start with these observations. I'm sure it's just what we're talking about there. It's like, and people really appreciate just what actually is gathered, what's collected. We've got conventional data, what I call in situ. That means that this is an observation which is taken by an instrument that's actually measuring what where it's located. Thermometer you hold up, you get the temperature of the air that's on the thermometer. There's a radius on weather balloons. This is a kind of unique or specifically interesting to us because we had a radius on station on the Philly airport. We showed it because it is local. I'm going to actually spend a little time talking about what's going on over there.
Are they still doing that?
Absolutely.
Oh, good.
Absolutely. Ship reports all over the world, aircraft, commercial aircraft, all over the world are taking weather observations constantly. But we then have remotely sensed data. This is where there's an instrument that's telling you something that's going on somewhere else. Satellites, obviously. Lots of them. Radar. Some of you may be aware, and if you looked at the radar that's sitting down near Copios Crossing, it actually shows us what the weather is at, what the weather is on the ocean. There's something that's, and I mentioned this earlier, about why it's the international cooperation is kind of unique in our business. Weather data is almost universally shared, even during the Cold War. Weather data was shared in all countries. Because everybody has weather, because it doesn't take attention to international boundaries. It's something that there's motivation to make sure everybody gets it if you can. And there is a dedicated telecommunication system just for weather data, globally transmitting weather data globally. To say it's a rare example of international cooperation. It works. It really does work. It's worked for 50 years. The daily volume observations taken globally is gigantic. I'll show you what we're talking about. Hundreds of millions every day. Obviously, it's overwhelmingly from satellites. That's about saying. The problem weather data is very perishable. Nobody really cares about yesterday's weather. You've got to get it out. You've got to put it to use as fast as you can. Literally in a matter of minutes or an hour and a half. After that, it's really rapidly losing its value. Here's a list of the kind of material. I'm going to try and go through and explain what all these things are. The ones here in the top, ship reports, radius on movies, aircraft. All these others, these are all the satellite systems of the variety stuff. When it comes to they measure things actually using microwave, infrared, GPS, thing called a scatterometer, which looks at the little capillary, the little tiny little waves on the ocean, not the big waves, the little bitty ones, because the wind speed actually just produces what we call these capillary waves, surface of the sea, the surface of water. And you can actually get a measure of wind speeds by looking at the backscatter from those little bitty waves. So just to see what those things look like. One of the things I want to just point out to you is look at the numbers here. These are 6 hour accumulations. In the weather business, everything is done basically in 6 hour blocks of time. Every 6 hours, you kind of go through and do the same thing. So we've got it here and kind of like out here, but I think these are the radius songs I think. These are unfortunately covered up some stuff here. But the important thing to look at is some of these numbers, total number of officers, order. Movies, so you can see, and you can't read it here, but this is from various countries that are contributing. So you can see that there's a lot of countries that are participating in all the time. This is aircraft. One of the things I mentioned, international cooperation, data sharing. One of the things that's kind of conspicuous here is Russia doesn't give anybody their aircraft data. They give you radiosondes. There's the radiosondes, and there's no problem. So for some reason, you don't want to have anybody see their aircraft. Chinese, no problem. They got lots of aircraft, lots of radiosondes. The Chinese weather service is really big time. Really very advanced. There's some satellite systems. Right. You can just see the swath, you see the numbers here. 1.4 million. 800,000. These are polar orbiting satellites, swaths. These are geostationary satellites, the kinds that sit up over the equator. Position. So we have here these two from this side, for example. These two are U.S. GOES geostationary satellites. East goes east and goes west. They've been had those for almost 50 years. The blue one and the red one here, those are European. I'm pretty sure this one is Chinese. This purple one is Japan. And that's this particular instrument here. Sure exactly what that is. What's this was radiance, so those are temperature measurements. For whatever reason, the Chinese don't see that kind of instrument. I might say too that which of the countries are involved, but in fact, it's much more international than that, because even though not that many countries are actually launching these satellite systems, the instruments that go on come from a lot of different countries. The Canadians, for example, have made a lot of sensors for the US satellites. Same thing with Europe. India, for example, is pretty advanced weather. Our community, they also do instruments. Here's just some more examples. This happens to be the GPS type data. It can measure temperature. GPS is used to measure temperature in the upper atmosphere. Because it turns out that there was when one GPS satellite talks to another, so that those radio signals go basically cut across the top of the atmosphere, and it actually bends, depending on the temperature of the atmosphere. That radio beam is bent. It's bending angle. There's that bending angle to temperature. Really fascinating. So this is just several examples. This is obviously not all of them. As I say, just the numbers here are the things. Every 6 hours. So let's talk about radiosondes. I say that this is kind of interesting for us because we have one. This is the most traditional weather observing device that we have. There it is. Weather balloons. More than 100 years. Launched twice daily. In the weather business, everything is keyed off Greenwich Mean Time. Everybody works that. It's called Zulu time. Let's see here. Zulu time. Pacific Standard Time, midnight Greenwich is 4 o'clock in the afternoon here. Launch, save in here. The launch for the ones over here is 55 minutes before that normal time at 3:05. 55 minutes before 4 p.m. There's the 12Z, that's 4 o'clock in the morning. Launch at 3:05 a.m. Standard time. The balloons rise to over 100,000 feet typically. Takes about 2 hours. They rise at the rate of about 5 meters per second, 16 feet per second. That's why they chose this launch time. So basically you get a time over the 2 hour, you basically straddle that nominal observing time. They're what we call synoptic observations. Synoptic is a synonym for simultaneous. And all over the world, everything is done according to 00Z and 12Z. Everybody works on that clock. So all this data becomes basically synoptic, simultaneous. Let's talk about Trillium. Officially designated KUIL, kind of a call sign. Moved from Tatoosh Island in 1966. That's when they closed the lighthouse, Tatoosh Island. And there wasn't a large observer out there. They had double duty, not only as lighthouse, but also a balloon launcher. It's arguably the most important upper air station in the country. Because it's the one that sits right there at the tip of the spear. Stuff comes in off the Pacific. That's what the first get any sort of observation of what's coming. And this is what's, I think, of particular interest. It switched to an automated system in 2020. And I'll show you some pictures here. Vaisala is the company. They're the gold standard for meteorological observing equipment in the world.
Where are they based?
Finland. Finnish. So here we go. I'm sure all of you have seen this funny looking building here. This is the old launch, the preparation building. The balloon was inflated in here. This was side wing was where they stored the hydrogen bottles, filled with balloons. This dome was for a radio receiver. In the old days, they used to actually transmit from the instrument back, and they would pick it up. Hear those and get those signals back. I don't think that's been used for some time, because now GPS instruments basically measure all that. We have to be right in place. This is my neighbor and Chip's neighbor, Mac Farrell. In the days before they put in the automated system, they had a crew of 4 that rotated, launched it, be up there at 3 o'clock and 3 o'clock in the morning and 3 o'clock in the afternoon every day. Rain or shine, launch the balloons, getting prepared. This was January of 2015, 2014, yeah, January 2014, 11 years ago. Getting ready to launch it. That balloon is about 5 feet diameter. The instrument is on the end of that long string. It's laying on the ground, hangs down below it. Now, this is this device. It's about the size of a shipping container. It holds 60 balloon sets of balloons and instruments. A month's worth, 2 days, so you got 60 days supply. Somebody has to come over from Sandpoint every month to resupply it, to replenish the supplies. Now, as I mentioned, it goes off at 3:05 a.m. and p.m. and it's keyed off a network clock, so it's exact. And so I drove over this day. It was about a month ago. And sat with my camera, okay, and watched my phones, because I got the same phone, same time on my phone, and I'm sure it is. It's about 5 seconds to 3:05. I started taking pictures. Click, 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 as fast as I could push the button. And I got one just as it cleared. Remember, it goes up at about 16 feet per second. So I got it just as it cleared the device, cleared the bay that it's launched from. And 1 click later, there it was. And I kept taking pictures, 3 or 4 more. By the last one, it was a dot in the sky. I got lucky because there's no warning. You just have to depend on that time, because there's no, it just opens and it's gone. And in this case, because it's being launched with this contraption, you might call it, they can't afford to have the instrument dangling on a long string from below, because they don't really get tangled. If the wind is blowing, it would almost certainly get snagged. So the instrument is really right at the base of that balloon. As I mentioned, it will go to over 100,000 feet. As it goes up, of course, the air pressure is decreasing, so it's getting bigger, bigger, bigger. And by the time it gets to 100,000 feet, it would fill this end of the room. And then it pops. And there's a parachute. Lets it down. And I'm sure, well, I'll show you in a moment here results of one of these sounds what it look like. But when the wind is strong, it gets me downwind a long way. In fact, here's a sounding. This is temperature from 1,000 millibars at surface to 100 millibars, about 30,000 feet. This is dew point temperature. When they're the same, it means you've got clouds. But these things over here are winds. Now, if you look at these things, you see one of the little dark triangle, that's 50 meters per second. Each one of those little lines is 10 meters per second. So you've got one here that's 50 plus 4 little lines, so that's 90 meters per second, that's 200 miles an hour. Jet stream. So by the time that thing gets to 100,000 feet, it's 150 or 200 miles downwind. It's over the Cascades. So it, sure, and that's in the winter, of course, when the wind and jet stream is that strong. So there's these things are scattered every 2 a day. They've been doing them from Pulliam since '66, so they've been doing it for almost 60 years.
Do we take stupid questions?
I'll even take, not just whatever you got. There are no stupid questions, only stupid answers.
So the balloon that wasn't automatic had a string to it and it came down?
Oh, no, it was also on a parachute. Yeah, they come, they just don't want them to hit somebody in the head, want them to come down gently.
And do any ever come down around Forks or all?
Well, there would have to be where there'd be actually no wind. Now, in the summer, when the winds are lighter, when you don't have those jet streams like that, they're coming down over the Olympics almost certainly. In some cases, particularly if the winds from the north, they might blow, it might, be on the west end of Falmouth, Jefferson County somewhere, hanging from a tree. That's what, I'm sure that's what where most of them end up, is hanging from a tree. Because you've got a parachute, but you've got all that debris from that balloon, it's gonna get tangled, whatever it lands on. But, and there is a little note on it, if you ever find one, there's a note, you can return it, I don't think they're reusable. The instruments are basically built to be cheap. They're built as cheap as possible. So it's just kind of it's not built to be disassembled. Let's put it that way. Encased in plastic. They gotta be durable. They obviously have to be able to tolerate going up through whatever whether you've got the full depth of the atmosphere. But they may be able to maybe use something from them, but they probably have a battery in there that can't be replaced. So I'm sure that when people find them, I assume this is what I'd be just a souvenir. Why not? I believe I've been told that they typically cost about $50 to $60 a piece. Manufacturing. Nowadays, that's not that much. So this is an example of what they're doing. Now I mentioned this goes to 100,000. This is what's called a skew T log T diagram. They actually go to 10 millibars. Another 60, 70,000 feet. So what do we do with this data? The problem, we have to construct a 4-dimensional image of the atmosphere from spot observations. That's the challenge. We want to get a picture of what the atmosphere looks like. Observations. And this is a ubiquitous problem in science. This kind of an image from spot observations, randomly distributed observations or measurements. In meteorology, it's for the initial condition from the models that we have. In geology, describing oil-bearing deposits. They either have thumpers on the ground or little small explosives. They put in the ground, they set them off, and then they get the listener somewhere else. And they see how long it takes that sound to be reflected back to the surface. So they can actually construct what the ground looks like. If there's oil, if there's oil there, that changes the speed in which these sound signals move through the earth. In oceanaric acoustic propagation, big deal for submarines. Medicine, CT imagery, MRI imagery. The mathematical term for this one is tomography. Our version looks like this. Don't worry too much about this stuff. Why are the observations, the X of A is that important? This is where the sausage is made. All the stuff in here, that's the math. So very expensive to solve for all these observations. Now, this is what's interesting. Personal anecdote. When I was a graduate student in Washington, a long time ago, it was about 1970. There was a computer center. So this was made 4 personal computers for the internet. You walk to the computer center from wherever the office was on the campus with a stack of cards, real cards. And you hand them to somebody over a counter, and they read them through a card reader, and you got your cards back. And then maybe later that day you would get some results back on computer paper. And in that computer center, by the way, it was heavily fortified. This is about 1970. Vietnam War, they were worried about being occupied. So they didn't want people to get messing around with that computer system. Anyway, on that computer center, there was a TV monitor. And you see the jobs that were running, the jobs that were in the queue. Hopefully you can see your own there from time to time. And there was a job that was running there constantly. Its name was X-ray. And we always wondered, what is that job? Because there had to be grants to pay for computer time. My advisor had a grant that I was using for my research. And we figured whoever that X-ray job, they got a big grant to be able to running basically all hours of the day and night. And we always wondered, what is that job? Strange job. It's always running. And sometime later, months, maybe a year later, I found that the University of Washington Medical School was a pioneer in CT scanning. CT stands for computer tomography. And they were running scans. They were running their version of this equation, processing CT scans on that computer. It was taking forever for the individual set of scans. It probably took, I'm guessing what we saw, it must have been taking 12 hours. Because the computer that runs this control data, 6400, which for the day was a capable machine. But it was that laptop there has 100,000 times more computer power than that thing had. And anyway, that's what was being run. Or that they were processing CT scans on a campus computer. And it was running constantly. They must obviously they had a very large range. You can imagine. So this is the business the side of business that I was in, the numerical guidance. All modern weather forecasting. It's based on products from national models. This is numerical weather prediction, NWP. But the guidance is not weather forecasts. It's guidance. It's information that meaningful meteorologists who are trained look at it and know what to do with it and how to put it together to produce a weather forecast that you would be able to relate to. What do you do to produce this guidance? NWP is what's called an initial value problem. In order to know what the weather is going to be tomorrow, next week, you've got to know what the actually looks like right now. So you need a model. You need a model the data well, you have some atmospheric frost and properties. The atmosphere, the air is a fluid. Very thin, skin of an apple. Look at typically, we have what's called scale density the atmosphere, particularly about 10 kilometers, 6 miles. Compared to the size of the Earth, that's really thin. The sphere, pretty obvious. The Earth rotates. This is what really matters. In fact, the Earth rotates is what really makes the weather. Makes the weather do what it does. Water in the atmosphere, and the sun warms the atmosphere. It's all these things, and some of us, we have a mathematical problem. That's the point of this is. And there's the mathematical problem, solving these things. They're hard to solve. Spend your career working on solving them. What are you going to solve them? We need one of these. This is the fastest computer in the world as of today. It's Name is El Capitan. Those of you been in Yosemite Valley know that this is El Capitan, this rock face right there. It's in Lawrence Livermore Laboratory. It's a government energy lab. And it's capable of 1 quintillion floating point operations per second. Floating point operations, add, subtract, multiply, or divide. It can do this many of those every second. There are weather services around the world who have machines, maybe not quite this fast, but they want one. They have one now that's not that far behind. And running one of the big global models, it will take an hour and a half. That running that thing, so you're crunching a lot of numbers. It's a problem.
Is El Capitan only used for weather?
No, this is at Lawrence Livermore, this is Department of Energy. So it's used for probably simulating bombs. But no, it'll be general purpose. Any number of different things. In fact, usually when they get one of these big machines, they will actually solicit big problems. And a lot of those big problems are weather. I'm pretty sure that this machine has run some weather, some experimental weather problems, probably some climate simulations. In fact, I know that Livermore was quite big in climate studies when I was doing that. I participated in what was called the Atmospheric Model Intercomparison Program, sponsored by them. Modelers from all over the world ran a 10-year simulation with their models and then compared the results. See which models were the best. The model I worked on was in the middle of the pack. But I'm sure that similar things are being done on like this, much more ambitious kind of programs. Now they're over many 1,000 years. So to show some examples of numerical guidance, I wanted to show stuff from the model that I worked on, but for whatever reason, the website has their products, the Navy's products have been off the air for several weeks. I don't know what's going on. So this is from the UW website, the Department of Meteorology. They run a model, limit area model for just the Pacific Northwest. This is from at the first of the year. Whether this week has been kind of boring, so I didn't see any point in showing in. Wasn't anything happening. We said it was chilly. So I chose this one mainly because this is 12 hours of rain, days of rain. Hour 24 to hour 48 in forecasting. It was kind of interesting. It should so conspicuous. It shows the rain shadow model simulating the rain shadow here in these coordinates. So also on the east side of Vancouver Island. Very conspicuous how this, for example, this dark blue, that's down here, that's half an inch, 24 hours. It was just a kind of a rainy day and here, no big deal. But there wasn't any swim, wasn't getting any rain. And all that came from stuff like this that they have on their website. This is what I call the numerical guidance. They said only meteorologists can relate to this. All this, every conceivable kind of thing, every 3 hours, just goes on and on and on. Thing that you're looking at there, just to show that's the map that I showed you where the arrow point. That's what you looked at there. Shows. Asking why. There's more. It just goes on. Here's snowfall. Everywhere you want to. Snow power. So you can see that only meteorologists are really going to want to deal with stuff like this. So now we get to what really should matter, probably matters most to you. The public forecasts, what I call the retail weather. That must be converted to sensible weather forecasts. The meteorological broadcast and stopping meteorologists that are called. they're trained in numerical guidance interpretation to be able to take all that stuff you just saw and make some sense of it. Construct. They usually have journalism training. Certainly, if they're getting up in front of the TV camera, they better know, they better be able to at least dress right. Most major universities have broadcast BS and MS programs in broadcasting. Certainly, University of Washington does. I knew some people in that program. Penn State. I know. I listened to them because I actually knew people from these places. Broadcast. Oh, that's obviously the TV weather forecast that you see in the evening news. The Weather Channel, it's been around quite a while. You know, they've done a lot to kind of glamorize the weather, you could say. The weather apps on your phone. A lot of you now use those. I don't, because I like to go back and look at the guidance. I'm in the business, so I can do that. This one is almost entirely non-governmental. In fact, there's an interesting thing here, is that the users of this data, they don't have to use what the Weather Service gives them, what the government provides. If they want to go out and do their own thing, that's fine. There's one exception in this country. It's hurricane forecasts. The National Hurricane Center issues the official forecast for hurricanes. And by law, nobody's allowed to deviate. They don't want any confusion about what people should do. And what I'm saying is hurricane forecast, landfall, where it's going to hit, what the strength is going to be, where the storm surge is going to be. They want people to listen to one voice, that one particular situation. Other countries, not so much. There's in Great Britain, for example, the UK Met Office issues official forecasts, and TV stations are required to basically take what they give them. They're not allowed to read. This is something of interest, public forecasts. I can remember, maybe some of you may remember, it's been 56 years ago. Channel 5 in Seattle had a forecaster on the evening news named Ben, and he was advertised as King's Cartooning Weatherman. That's what, and he would draw cartoons, figures on his screen on his presentations. Just kind of make it lighthearted. You don't see much of that anymore. They're real. No, he was a meteorologist, but basically he could tell you, well, it might rain tomorrow, but beyond that, he really couldn't say much more. This was the days before satellites or anything like that. So it was pretty well together. Except for maybe tomorrow, which wasn't a whole lot of skill. So here we go. Let's talk about AI. AI stands for artificial intelligence. Not in business in 50 years too soon. I'm thankful for that. Well, I do watch the proceedings of major conferences. And I've been looking at them. It's a big deal. It is a big deal all over the world. So I'm going to give you what I would expect AI, how it was going to have a major impact. Basically, just from what little I know about it, from what I've been reading. What is AI? It makes human intelligent intuition and hopefully it learns from experience, just like hopefully we do. But it has the advantage of perfect memory. It never forgets anything. Certainly unlike me. And access to all human information and understanding since the beginning of time. It sits on top of search engines and everything. So if it's anywhere, it's written down anywhere, it's going to find it. And this is what's different. New technology, when it came along, gave us tools. And we were able to solve harder problems, solve them faster, do it better. But we still solve the problems ourselves. They were tools. A is different. We're gonna be like clients contracting with this thing to solve the problem for us. That's the difference. So we're gonna have to describe the problems, solve, and then negotiate with that AI thing. You know, figure it's got right. Three way of solving problems will not be without pain. For sure. Sorry, I didn't twice. But what it said was, ultimately, that AI thing is gonna be smarter than we. And it's gonna start talking back. And then how we're gonna deal with that. It's not gonna be easy. So the observation processing, it's quality control, identifying bad data. That's the essence of things. The data all has error, and sometimes that error isn't acceptable. We have a general saying in the business. Accepting one bad observation will do more damage than rejecting 10 good ones. So we really have to be careful. Adjusting in those errors is critical. And we do have what we call objective quality control, a very simple tests. Very simple, pretty. Because the time it takes the volume data and the time pressure, you just can't do much more than that. And but the GTS data streams, the stuff that comes over that telecommunication system I talked about, there's very little except just the data. You don't know anything else about what was going on at the time around that location where it was. Back in the old days, before there were satellites, the number of observations was pretty small. So meteorologists, guys with green eye shades, sitting in a light table, and sit down and plot the observations by hand on the map. Draw contours, draw fronts. These things are works of art. These guys were reading what they were doing because there was enough. There was the number of observations was small enough so they could do that. Treat each one individually. Decide that was sort of suspicious. And they could pick up the phone and they could call whoever took that observation. Hey, what was going on back there? Look at that location. And the World War II D-Day forecast. It's a classic example. There was, as you might imagine, not very many observations. We had to make a forecast of D-Day. Eisenhower wanted to know whether it's going to be safe to go. And there were a few ships. There were some boats. There were some aircraft. There were some observations from the west coast of Ireland. Ireland was neutral in the Second World War. But apparently politicians looked the other way. Let people on the west coast of Ireland send data to the forecasters for D-Day. And they were able to sit down and you know, like I said, draw some pictures, scratch their heads. They were all very experienced and do the best they could. And they actually did delay the landing a day. They said, you don't want to go tomorrow, or but the next day is going to be okay. And they were lucky. They got lucky. Well, AI, you'll be able to do that in spite of the volume of data. You have enough computer power, you'll be able to do that for sort of thing with the kind of volume of observations that we have now. It's just like having a million of these guys with green eye sheets. Choices. And that's the thing about using human intuition. It'll be a while before they can pull that off. That's I'm sure one of the goals of AI in the business is that very thing. And I just show you an example. Here's that sounding I showed you. It was 4 p.m. on December 25th. There's 6 hours on either side of it. So we had a whole bit of information this is from you, what the cloud cover was. Scattered, broken, overcast, where those cloud layers were, whether it was raining or not. So that's the sort of information that might be of interest, might be of use to somebody who's actually trying to do hand analysis. AI could presumably take advantage of information like that. Make some judgments about that sounding we saw. So this is the one of interest to me. We'll not replace those equations that I showed, nor how they are solved. He's going to replace those equations. We replace people like me, right? That can really go and solve those equations. The model I worked on had about 3 million lines of Fortran code. I didn't write them all by robot. Fortran is the language that the university used in high performance computing. It still is in the areas like meteorology. Be able to do it better than I did. Well, let's see. I went on the internet and I found, Fortran code generator. Tell us your problem and we'll give you the answer. So I said, write a Fortran program to solve a system of linear equations using Gaussian elimination with full pivot. Maybe you remember, if you took high school algebra, how to solve 2 equations with 2 unknowns, 3 equations with 3 unknowns, simultaneous linear equations. That's what this does, except this can do it with thousands of equations. So it's a computer program to do that. And it did it. I'm sure what it did, went out on the internet somewhere and found a software repository and picked it up and tweaked it a little bit and gave it back to me. And that's okay. A lot of software is written that way. So, okay, let's try something a little harder. So I gave it this problem, and I want to go through the details of what it was. This is basically the sort of thing that might be shown in a class in numerical weather prediction. Like when I was in Monterey, near postgraduate school, taught graduate programs, graduate class on numerical weather prediction. This is the sort of thing that they would do as a class demonstration. And it failed miserably. It didn't understand basic numerical methods. So this site was not up to the task. Okay, let's try something else. So I went to Google and they have this AI thing they call Gemini. I said, well, let's give it a shot. So I give exactly the same text here. And it understood most of it. It knew the numerical methods, but there were some details that it didn't get right. And I'm sure I could have gone in and probably negotiated with it a little bit, iterated, and got some answers. I said, well, I've got time for that. It's not that important. Clearly, it's on the right track. I said, and there's this thing up here called Gemini Advanced. No, maybe that'll be the job. So I clicked on it. 33 for the first 30 days, then $20 a month. And I said, well, no, I don't need to do that. But no doubt, if I really were serious about this, that's probably where I would have gone. Something like that. Get the best they got. See if I could move over equals. So anyway, that's for the stats. So there's still a ways to go before it, I think it would take much up. And lastly, here's the AI and retail weather stuff that you're reading. So I'm going to repeat here. These are exactly the same bullets that I showed in the previous slide when I talked about the retail weather. Same ones. This is a major order for AI. These tasks. Let's say. This is really right now. Do this question in my mind. A lot of some broadcast meteorologists out on the job. Are we gonna have an avatar on TV giving us our weather? I don't know. We'll see. Instead of our human being. They're most likely to take over soon. The military. We had a terrible time in Afghanistan. They didn't have any gold. They didn't have any meteorologists, knew anything about the weather in Afghanistan. AI was really able to find whatever information there is in the world about whether in Afghanistan, it'd be able, you find it and use it, do a better job than what they have. The phone apps, I suspect that they already are, once you're using them. What are the derivatives? This is interesting. Remember Enron? 10, 12 years ago, not in a lot of trouble. One of the things they did, however, that worked, legitimate, was they wrote what they call these short-term insurance policies for whatever things are industries. Think of a ski area that wants to open next week, but they don't have enough snow. But if they want to open next week, they got to hire staff. They've got to get their equipment ready. So they this Enron, for example, would sell them insurance policy. Say, we'll sell you this policy and guarantee that, or promise that if you don't get the snow, we'll pay for your expenses. Preparing. Of course, what they did was they were looking, they had the best possible, they had a lot of meteorologists, they had the best guidance they could get, the European centers, which is the best system in the world. And so they had a pretty good idea what the weather was going to be next week at that particular location. But if you really want to do this on a mass scale, this is where AI could really work for you. Because it would be able to take all the numerical guidance there was from anywhere they want to go, and they'd be able to tell them, okay, you can write a policy for this because we think the forecast is going to verify it, so they're not going to have to pay off. Public utilities, electric utilities, agriculture. Think of the places where the sort of short-term insurance policies would really be worthwhile. I think that's going to be a big place for AI to play. Obviously big opportunity for the private industry. Just imagine. Add value to the guidance. So they're going to, meteorological professionals will be dramatically change. They're going to end up being basically clients with AI that's actually. In summary, big science and big business, international cooperation, collecting data, all of whatever market depends on guidance, retail products for public use. AI will have a profound impact on science and how it's done. Business, I wanted to stay up with a minute. NWP depends on the world's fastest computers. Fastest computer in the world. AI will have even greater requirements for computer power, therefore electricity. You may have heard, some of you, Microsoft and this company, Constellation Energy, plans to restart 3 Mile Island nuclear plant. Only half of it, 1979, down. Still, half of that's still intact, even though it's been sitting idle almost 50 years. I'm not sure it's the best, pretty obsolete. Okay. Microsoft will buy all the electrical power just because they want to run an AI server center in Pennsylvania for Microsoft Copilot. That's the whole point. It's just run AI. All the electricity would have to produce. Just think about what this is going to think electric vehicles are going to have an impact on our electrical requirements. This one would dwarf that. It's already have an issue. There are places in the country where companies can't do AI. They can't run AI server because there just is no electrical capacity in the grid in that area. Microsoft is willing to go into a situation like this. Okay, questions and discussion. Right at 8 o'clock. Anything?
I recall when my first couple ships, we in the early 70s, we didn't have satellite forecast. So our weather guesses were always going out and doing what bowl, ground bowl, and then they go and shop and they do their maps and everything. And the drawback was, we got caught in a couple of hurricanes. You know, there wasn't that much of a forecast on what was going on. If you're out in the ocean, you
Oh, yeah. Until the days of satellites. Hurricane forecast, anything in the open ocean, it was, you were blind. You were blind.
before I retired, you know, we get the satellite maps in, it was great. The boys
No,
was fun.
You know, there's a story about Admiral Halsey. In the Second World War, he was told, hey, you know, there's a typhoon, it's the Western Pacific. There's a typhoon in the area, we better be careful, we better go and find and go around. He said, no. He was false, he didn't take it. He just went, Bo Halsey. He lost several ships because he ignored guidance. It wasn't guidance, it was the meteorologists had enough, there was enough observations. They knew that there was a typhoon somewhere in the area.
Somewhere,
Somewhere.
it's always fun.
Oh, there's always information that's like to go to one central location.
You know, there are several major centers, communication centers around the world. There's one in Melbourne, I think there's one in Moscow, there's one in Offutt Air Force Base, Nebraska. Tokyo, I think. So everything kind of comes down to satellite stuff. Actually, they're even more than that because you can't afford to have the thing go full orbit. That's typically 90 minutes for an orbit for a typical satellite. You can't wait that long. So you have to after you take the observation, you want to get it to the ground in a matter of minutes. So there are several stations, ground stations, just the satellite that goes there. And then they send it to these major centers in these cities.
People want that information, they have to subscribe. Or is it just,
It's pretty much government to government. There are sites where you can go, you know, basically repositories of the data, so private companies can get it. Probably not all of it, and perhaps not quickly. In other words, it's gonna go to the major weather centers first, and then after that. But there have been some efforts, and for example, I mentioned University of Washington. They run a model, but they're getting the data from the National Weather Service. So they actually get it kind of probably just a few minutes later than the Weather Service does.
You hear a lot about the European weather model,
The ECMWF,
Yeah,
European Medium Range Weather Forecast.
and it's more accurate than anything.
It's they started in the late 70s with the mission, which European companies got in, that the goal of the 10-day, skillful 10-day weather forecast is their goal. And they put more research. They made, we're going to have the fastest computers. We're going to have the best talent in Europe. We're going to pay them very well. They do. European Center, it's very lucrative assignment because they were usually from their host countries. They would get to go with the ECMWF for 2 or 3 years, made 3 or 4 times as much money. I've been there about 10 times over the years. It's a very impressive place.
What makes them more accurate? Or
It's
is
just
that
effort. It's effort. That computer you saw there, that represents effort. Just you're able to run higher resolution. You're able to do more with the data. It's just, and the best talent model is tested more and best physics they can produce. It's just, you know, it's like Edison said, inspiration or invention is 5% inspiration, 95% perspiration. That's what the same thing in this business is. It's just effort, putting the best people in the most resources. And they just, all they worry about is that 10-day forecast. Their useful skill now is about day 9. And over the years, pretty much everybody has seen we get a day's improvement in forecast still every 10 years. So in other words, the forecast now at day, see, I have to make sure I always get this right. The forecast now at day 8 is as good as the day 3 forecast was in 1970. It's 50 years.
Where is that,
75.
where is that center?
Reading, England.
Where?
Reading, England. West of London, about 50, 60 miles west of Dublin. West of London. Yeah, first time I went there was in 1978. They rolled up the sidewalks. 10 o'clock. Last time I went there, it was a wild place, high tech place.
And it seems like the biggest thing facing us today comes for your balance. The hybrid on the wheel and the electric, range. Which is, I didn't think it's fun.
Well, probably to design batteries. Like I say, it's just, you can tell what you want and then whatever. Science will allow us to do.
That's the ball that was,
Storing it is a big challenge. Right? That's why I don't think the 3 Mile Island is the solution, but I think the modern current technology for nuclear plants is more attractive, I think. Yeah.
Right?
Well, nuclear won't store it, generate, plant to generate electricity, boil water. Boiling water. Yeah. That's what they do.
Yeah, I was back there about 18 miles away from 3 Mile Island when all that was going on. Metropolitan medicine was lying through their teeth. You know, the state was flying at altitude and they were picking up way higher levels of radiation. You know, well, it was almost exactly like the China syndrome. I mean, they said if the plant fails, it'll contaminate an area the size of Pennsylvania. And I mean, it was crazy. I mean, and they're lucky the reactor didn't completely rupture. It was mostly just tritiated water. Yeah. And then I live right across the Susquehanna River from the Peach Bottom nuclear power station. And one of the safety engineers that worked there, we were talking one day, he said, that plant's less safe than 3 Mile Island. So I moved 3,500 miles west, trying to get, you know, upwind a ways. And then they sent the tritiated water out to Hanford from 3 Mile Island. It followed me part way. But I had a question regarding, you know, you said with hurricane weather data, you have to use the government source, basically.
Well, for prediction of things like landfall, where it's going to landfall, where the storm surge is going to be, they don't want the public to get mixed messages.
Conjecturize.
Yeah.
I was wondering, what about fire weather? You know, it seemed like that is, yeah, I'm just reading a book right now called
Well, current situation.
I was reading one about back in 2016, it was Fort McMurray, way up in Alberta, and the whole town, I think it was 90,000 people, and they just totally ignored the signs. I mean, they knew this monster fire. I mean, they had firestorms going up, they said 1,000 feet, and they ignored it, basically. I mean, the provincial and the municipal fire authorities, they didn't evacuate till the last minute. I don't think anybody died, but it ate up. It's a great book. It's called Fire Weather, and it gets into global warming too, but it talks about this specific case that was just unbelievable that they didn't tell people to get out of there. They said, well, just, you know, continue, shelter in place and go about your business and blah, blah, blah. And then they look up and there's this great big black column with red shooting up through it. It's jumped across the Athabasca River. They figured, and they made huge fire lines with like D11 cats, bladed off all the vegetation. it just was spot firing the whole way across the city. It was crazy. And they just ignored the weather. I mean, they knew the wind was gonna change and push it. And it was, 90 degrees in May, in Alberta. I mean, they say that's when they have a lot of fires up there, and the fuel
Well,
levels.
that's, you can always say, who's at fault there? It's always somebody to blame, so
Well,
I don't think that's.
yeah, this one fire crew came from Slave Lake and their town had been, a third of it had been burned up. And some people came up from there to bring a sprinkler system to Fort McMurray and he told, this guy from Slave Lake told the fire.
Is that a problem with the weather forecast, or is people not using?
They didn't pay any
Well,
attention.
that's.
I mean, the weather would have.
So blame them, don't blame the weather.
Oh, I'm not.
Well, I know, but we're not here to, I'm here to talk about the weather.
Right.
I don't care about the public,
But I mean,
public officials.
yeah, I don't know how good was the weather predictions in Los Angeles?
Oh, we're very good.
Right on for wind speeds.
Oh, yeah. Yeah, there again, I think it's public officials.
Oh, yeah.
That's, I don't think we really want to get to that.
Mhm.
Okay, we haven't heard anything from the Zoom, any of the Zoom audience have anything?
Yeah, no questions so far in Zoom. Just a comment from Roy and Nancy that says, thank you for a very well prepared and delivered presentation. Your depth of knowledge and commitment to serving others by informing them in ways that we can better understand the world is inspirational to all of us.
Thank you. Anything else?
So two questions actually. So first off, is there a date going on fire thing and what's going on in LA? Is there like specialized models for firestorms or?
Well, there's very, very high resolution models were run. Basically, you have to be able to represent the terrain very accurately.
Right.
Under circumstances. Yes. What's a model called the NAM. It's an acronym. Don't really know what that actually. Very high resolution. Now the model, that one result that I showed you from the University of Washington, that was run with the model with 1 1/3 kilometer resolution. That would be model almost very close to capable of predicting what you need for fire. That model would actually be. And
then just because I wasn't sure, I don't know if you said, with the production of the, was it numerical guidance on supercomputers, is that still run batch or is that more real time?
well, everything is batch. Yeah, it's obviously very high priority. When it's time to run, it gets the computer.
Is that every 6 hours as well?
Oh, yes. I mean, I didn't want to try to get into the actual, all the details of what all happens, it's a pretty complicated process. Yeah, basically, everything's blocks of 6 hours, 6 hours of data. And then you have to typically, like showed you those nominal 4 a.m., 4 p.m., 00Z, 12Z. Most centers will try to get their forecasts running about 3 hours after that. All the data they can collect, can't actually wait for all of it. Because if you want to start your forecast model at 3 hours after that 00Z, that's 6 hours. Remember, that's the middle of the 6 hour window. So you're starting your model right at the end of that window, but not all the data is. It doesn't arrive instantaneously. Some of it's still on its way. And they do what's called a post time, where they actually do it some hours later. But anyway, typically you want to get everything's going about 3 hours after the forecast. That was a day of time. And typically take an hour and a half to 2 hours from the forecast.
One thing I'm trying to get to stop raining at 10. I was out for it. Start raining at 10, it's gonna quit raining at 10.
Well, you're probably talking about You guys, when they're looking at the real-time radar. That's where you can get that kind of information. You can look at those blobs, and that's real time. Those blobs on the radar, you ever look at the radar? Yeah, you can dock the radar, and you can do that yourself. You don't have to let them tell you. You can see that thing, see where it's moving. You just watch it move and say, it's gonna put rain in 10 minutes. That's the way I time my bike rides. I look for that 90-minute window between the blocks. Anything else? All right.
Thanks, Tom. That was really great.
Now let's see if I can get out of this.
Did a good job, thank you.
Yeah, your way out.
Oh, I have a question for you, Joe. The water, a little water.